Hello, my name's Bob Ladd. I'm an Emeritus Professor of Linguistics at the University of Edinburgh, and I'm going to be talking about the linguistic aspects of singing in tone languages today. I'd like to acknowledge the work of my colleague James Kirby and my student Albert Lowe, which is part of what I'm talking about here. Now, the everyday formulation of this question about singing in a tone language is that it's kind of puzzling or mysterious. How can they sing in a tone language? If you've got the pitch is supposed to be telling you what word it is and you're supposed to be singing, it would seem that there's a difficult conflict. But we can turn this into a proper research question rather than simply a puzzle. One possible formulation is this: how can the lyrics of a song in a tone language be understood? This is the title of a paper by Patrick Wong and Randy Deal from 2002. What Wong and Deal did was an experiment with native speakers of Cantonese. They manipulated the melody of a song so that the same segmental word, but with a different tone, would mean something different. And they manipulated the melodies and asked people which word they heard at particular key points. And they showed that that manipulating the melody of the song did indeed affect which words people understood. So that's one formulation of the research question, but it may actually not really be a very good one. If you think about it, why should it be mysterious? So there's lots of redundancy in language, lots of other sources of information about what the speaker is saying. Song texts are often very formulaic and predictable. They're often repetitive. You get repeated choruses and so forth. So that if the tone information is lost, it may not affect comprehension that much. We can fill in from what we know about the semantics and pragmatics. And we can also fill in from what we know about the phonetics. There are often multiple phonetic cues to phonological distinctions, including tonal ones. So if you think about it, it may be like asking, how can they whisper in languages with voicing contrasts? And nobody worries about this. In a language with voicing contrasts, there's no voice. There's literally no voice. But we don't have any trouble understanding whispered language for all these reasons, the semantic, pragmatic reasons. We expect kinds of words, and there are often some additional cues to the voicing, the phonological voicing of a particular sound that are not just in terms of the voice itself. So it may be the wrong question to put it in the way that Wong and Deal did. So let's look for a more general formulation of the research question, and we can put it this way. How does the use of voice pitch for musical purposes coexist with the use of voice pitch for phonological purposes in a tone language? And it appears, surprisingly perhaps, that part of the answer is the existence of text setting constraints, so that there are limits on the possible ways in which linguistic tone sequences can be matched with melodies. And most of the tone languages that have been investigated, or possibly all of them, seem to have constraints of this sort. And this is what I'm going to discuss in this talk. Now, before I do that, I want to briefly talk about the notion of text setting constraints as well, to avoid giving the impression that this is a strange peculiarity of tone languages. We have text setting constraints in European languages as well. But in the European languages, they're very often based on stress. So I'm going to use a simple example from English, which should be familiar to everyone. We take the Happy Birthday song. So here's the third line. We have happy birthday to you, happy birthday to you. Then the third line is happy birthday, dear Susan, or whoever the person is who's being sung to. And we're not aware of any text setting constraints operating here. But in fact, if we change the name, we can see that they are. So instead of singing it to Susan, let's assume that it's Suzanne's birthday. So we get rid of Susan here, but Suzanne, and we can't simply replace the syllables one note by note. And every 6-year-old English speaker knows how to do this. If you go to a 6-year-old children's birthday party, they all know how to sing this line of the song for whoever's birthday it happens to be. Well, what do? We have to rearrange the alignment of the name and with the notes, and we're doing it on the basis of stress. So in the first version here with Susan, the first syllable of the name is stressed, and it goes on the downbeat, the first beat after the bar line at the end of the line there. Happy birthday, dear Susan. But in Suzanne, the stressed syllable is on the second syllable, and we need to line that up with the beat and not line up the first syllable, which is unstressed. So we move the first syllable back, shorten it, and then make 2 notes out of the single stressed syllable Zan. So we get happy birthday, dear Suzanne. And as I say, every 6-year-old English speaker knows how to do this. And so an informal statement of the English text-writing constraint, just roughly speaking, is don't put a reduced syllable on a downbeat, an unstressed syllable on a metrically prominent musical note. And that's what we achieve by shifting the Su of Suzanne back and then stretching the stressed syllable Zan so that it covers 2 notes. Okay, that gives you an idea of what text-setting constraints are, how they might work, how they affect things, and how they feel really quite natural. Now I want to look at the kinds of text-setting constraints that we find in tone languages. And an informal statement of a constraint that seems to work pretty widely in tone languages of the world is if the musical melody goes up from one note to the next, the linguistic tone on the corresponding words should not go down, and vice versa. So more generally, another way of putting that is the pitch direction from note to note in the musical melody should match the pitch direction from tone to tone in the text. And that seems to be the basic principle that many tone languages follow in their text-setting constraints. So something like this seems to apply in lots of tone languages. I put some references here, but it's probably clearer to see an actual map. So what I'm saying here is based on a number of languages that have been investigated, both by James Kirby and myself, and various other colleagues and students and people in different parts of the world. And you can see that we're dealing with a good selection of tone languages, both from Africa and from East and Southeast Asia. They all, one way or another, seem to be doing this same thing of trying to match direction. Now, how do we know that this is what they're doing? Well, there's anecdotal evidence from problems in matching that come from European missionary activity in places where they have tone languages. This is an example from Aaron Carter Enye's thesis. A fine Protestant hymn, very stirring melody, All Hail the Power of Jesus' Name, which was translated into Igbo. And you can follow along there. The Igbo text is All Hail Power Jesus. Jesus' name is not, the name is not there, but Oha means all, Kele means hail, Ike means power, and Jesu means Jesus. Unfortunately, simply putting these things into the English melody doesn't work, and you can see a couple of clear mismatches. So the initial rise, all hail, is being used on a word that stays low, Oha. And later on in the line, we've got Ike, which is high, being set to a falling melody of G. And unfortunately, this has an effect on the way this is heard by native listeners, native speakers of Igbo. And here's Carter Henry's gloss on this. So because of the rise in the musical melody, instead of hearing oha, all, Igbo listeners hear oha, trees. So we've got trees hailing Jesus. And unfortunately, they're not hailing his power, Ike, but they're hailing his bottom, Ike, because of the falling melody in the falling melody in the music. So these kinds of anecdotes are found wherever there have been European Christian missionaries translating hymns into tone languages. This is not the only such anecdote. But obviously we want to get beyond anecdotes, convincing as they may be. Anecdotes suggest that the first of these, there's lots of actual research questions that we could do to get beyond anecdotes. It really does seem, both from the anecdotes and from Wong and Deal's experimental evidence, that listeners do interpret songs according to the constraint. But what I'm going to focus on for the rest of the talk is, do singers and composers actually obey this constraint? And the first question that we need to ask then to make this more rigorous is, how can you tell? So we need to look for empirical evidence for this basic constraint. And that's going to require some definitions. So we've defined terms for three possible types of, three possible ways that the tone direction and the melody direction could match. So it could be similar, that the musical pitch direction and the tonal pitch direction moving in the same direction across a bigram, a pair of notes. So the bigram is the first note and the second note, and then you look at the next bigram, which is the second note and the third note, and so forth and so on. So if the setting is similar, we've got the pitch moving in the same direction. If the setting is contrary, we've got the pitch moving in the opposite direction. And if the setting is oblique, we've got one of the pitch directions moving and the other one staying the same. These terms are borrowed from traditional, sort of distorted from traditional Western music theory. Let me illustrate more clearly. So here are examples of these possible types. So first of all, in black, the similar setting, we've got the music going down and we've got the tone going from high to low. In red, capital letters, red, the contrary settings, we've got the music going up, but the tone is still going down from high to low. Now, oblique, there's two possibilities. On the one hand, the music could stay the same. So here we've got two consecutive identical notes, but the tone is either going high-low or low-high. And on the other hand, we could have the music going up in this case, and the tone staying the same, high, high, and low, low. But these are illustrations of these types of bigrams, similar, contrary, and oblique. And I should add that Schellenberg and McPherson and Ryan, who've done the most similar work to what Kirby and I have done, are using very similar terms and concepts. There are minor differences that I won't take the time to cover. But now, we can visualize now for any piece of music or a corpus of music, we can see that we're going to have 9 possible types of bigrams. So there's 3 similar possibilities when the music is going up and the tone's going up. The music's going down and the tone's going down, or the music is staying the same and the tone is staying the same. So that's on the diagonal, similar, similar, similar. Then we got the 2 contrary cases, one where the music goes down and the tone goes up, and the other where the tone goes down and the music goes up. And then we've got 4 possible oblique cases, and we'll see that this is maybe a bit of a problem. So on the bottom row, we've got two obliques where the music is going up or down, but we've got a sequence of two identical tones. Then in the right-hand column, we've got two other kinds of obliques where the tones are different. So the tones are going up or down, but the music is staying level. But so this 3x3 matrix is what we can use to make predictions based to test our hypothesis about the musical constraint. So specifically, we might predict that the similar settings on the diagonal, the black ones, should be good if our constraint is right, and the two contrary ones should be bad. And we don't have a clear prediction about oblique, but might be okay. So concretely, that's going to translate into an empirical prediction like this. We're going to predict that in a corpus of songs, we count all the bigrams, and we would predict that the similar ones on the diagonal, the black letters, frequent, up, up, down, down, and level, level, should be frequent in the corpus. Contrary ones should be rare. And the oblique ones should be possible. Again, we don't have a clear prediction about that, but they ought to be possible. They ought to occur. And here's what we find in two specific cases, two specific studies. Kirby and I looked at Vietnamese so-called new music. This is westernized music since about the 1950s. And my student Albert Lowe looked at Cantonese pop music mostly from the 80s and 90s. So if we put actual numbers into this 3x3 matrix, here's what we find. So for Vietnamese, if you look at the black numbers on the diagonal, you can see that there's many cases of similar settings. Specifically, out of this corpus of over 3,000 bigrams, 3/4 of them are on the diagonal. Contrary ones are quite rare. There's only 5% in the whole corpus. And if we look at the oblique cases, there may be a difference. If you look at the bottom row, it looks as if cases where the tone is the same but the music moves seem to be okay. It's not so clear in the right-hand column where the tones change but the music stays level. They seem to be less common. We see that pattern even more clearly in Cantonese, where nearly 5/6 of the bigrams, this is slightly fewer, 2,600 bigrams, nearly 5/6 of them are similar. Only 3% are contrary. But if you look at the right-hand column, you can see that cases where the tones are moving but the music stays level are even rarer than the contrary settings. So we're going to have to do something about oblique. But in general, we can see that very approximately this constraint seems to be realized, seems to be manifested in a corpus of actual songs. So where do we go from here? Is that all there is to it, or have we got new things to ask? In particular, we might want to know, are we missing something by reducing everything to a 3x3 matrix? Now, McPherson and Ryan come up with very similar results to ours, and they confirm that this basic picture applies in their African study as well as in Asia. But they emphasize that a single aggregate rate of tone-tune association calculated across a whole corpus obscures a great deal of complexity. And we've just seen that in the Vietnamese and particularly Cantonese data, that we can say 3/4 or 5/6 of the bigrams are similar, but that doesn't tell us anything about what seems to be a problem with the definition of oblique. But I'd like to suggest that these are now tractable research questions. So we can refine our definitions. We can see, is oblique really a useful category? Well, probably not. Something I haven't even mentioned is we've focused only on pitch direction, but we haven't looked at pitch interval. In other words, is a big jump different from a little jump? Is a big drop different from a little drop? McPherson and Ryan discuss this, and it looks as if interval might be important as well. And another question we haven't mentioned is, how do we define up and down with contour tones? So to go from high tone to low tone, or low tone to high tone, it's clear enough whether you're going up or down. But to go from rising tone to falling tone, should that count as up or down or same? Is, again, another whole potential definable, tractable research question. And we can also ask larger questions like, do all languages and musical styles work this way? What does it tell us about tone perception, that the pitch direction counts? And if we think about the existence of text setting constraints in English and in tone languages, what does this tell us about the formal properties of text setting constraints? There's lots of larger questions that we could look at as well. So there's more to do, but I'll stop there. Thank you.